Welcome to the Observability and SRE practice series from the AI Mock Interviewer Question Bank. Observability and SRE Part 1. This episode has 13 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. SRE or reliability. Alert fatigue. You inherit 500 alerts and noisy on call. How would you rationalize alerts using slows and ownership? Here's a strong way to approach it. Start by measuring which alerts actually fire and how often they lead to real action versus being acknowledged and ignored. This data alone usually reveals which 80% of alerts to cut or tune first. Rebuild the remaining alert set around slow burn rate and clear user impact signals rather than low-level infrastructure metrics. Assign every surviving alert an explicit owning team, and require a runbook link on each one. Anything that can't meet that bar gets deleted or demoted to a non-paging dashboard signal. Nice. Let's continue. Question 2. Observability. Observability maturity. How would you assess whether an organization has mature observability or just many dashboards? Here's a strong way to approach it. Mature observability means teams can answer why is this happening quickly during an incident using correlated logs, metrics, and traces. Not just look at pretty dashboards that were built once and never revisited. Assess it by checking, are slows defined and tied to alerts? Can engineers trace a request end-to-end across services? Is there a consistent structured logging or correlation ID standard? And the real test. How quickly did the last few incidents actually get root caused using the existing tooling versus relying on ad hoc debugging? Great. Moving on. Question 3. Networking. TLS rotation. How would you rotate TLS certificates for production ingress without downtime? Here's a strong way to approach it. Use a certificate manager, Google Managed Certificates, or Cert Manager in Kubernetes, that automates renewal well before expiry rather than manual rotation, and ensure the load balancer or ingress supports hot certificate reload so serving traffic isn't interrupted during the swap. Monitor certificate expiry proactively with alerts at multiple thresholds. 30 or 14 or 3 days, as a safety net in case automated renewal fails, and always validate the new certificate is actually being served correctly, not just issued, before considering the rotation complete. Alright, next question. Question 4. GCP services. Artifact registry. How would you design artifact registry repositories? IAM, cleanup policies, scanning, and promotion between environments? Here's a strong way to approach it. Structure repositories by purpose or environment, e.g. separate dev and production repositories with IAM scoped so only CI or CD service accounts can write, and clean up policies that automatically remove old, untagged, or unpromoted images past a retention window to control storage cost. Enable automatic vulnerability scanning on push, and promote images between environments by copying the exact digest, not rebuilding. So what was scanned and tested in dev is bit for bit what reaches production. Let's keep going. Question 5. Automation or platform. Immutable infrastructure. What does immutable infrastructure mean in cloud platforms? And when is mutable infrastructure still acceptable? Here's a strong way to approach it. Immutable infrastructure means you never modify a running instance or container in place. Instead you build a new image or artifact with the change and replace the old one entirely, which eliminates configuration drift and makes rollback trivial. Redeploy the previous artifact. Mutable infrastructure is still acceptable for things that are genuinely stateful and expensive to recreate, like a long-lived database VM where in-place patching is more practical than a full rebuild and migrate cycle, though even there, automation and consistent configuration management reduce the risk mutability introduces. On to the next one. Question 6. CI or CD or GitOps. CI or CD design. Design a safe promotion workflow from commit to production using GitHub Actions, Cloud Build, Jenkins, Artifact Promotion, Approvals, and Rollback. Here's a strong way to approach it. Trigger CI on commit to build, test, and produce one immutable artifact tagged with the Git SHA. Scan it for vulnerabilities, and promote that exact artifact through dev leads to staging leads to production by updating deployment references rather than rebuilding. Gate production promotion behind a required approval. a human reviewer or automated staging metric check, and keep the previous production artifact reference readily available so rollback is a fast, low-risk redeploy rather than a new build under pressure. Good. Here's another one. Question 7. SRE or reliability. Slow burn rate. Explain multi-window multi-burn rate alerting and how you would tune alerts for fast and slow burns. Here's a strong way to approach it. Multi-window multi-burn rate alerting pages on a combination of a short window, catches fast, severe budget consumption quickly, and a longer window, confirms the burn is sustained, not a brief blip evaluated together, which reduces both false positives from transient spikes and false negatives from slow but real degradation. Tune fast burn alerts to page immediately at a high burn rate over a short window, e.g. consuming a day's budget in an hour, and slow burn alerts to create a lower urgency ticket for sustained moderate consumption over a longer window, e.g. a few days, since the appropriate urgency differs. Nice. Let's continue. Question 8. Observability. Cloud Composer or Dataflow. A scheduled data pipeline misses its SLA and downstream dashboards are stale. How would you debug Composer, Dataflow, BigQuery, retries, backfills, and alerting? Here's a strong way to approach it. Check the Composer or Airflow DAG run history first to see exactly where the pipeline stalled or failed. Then check the underlying Dataflow jobs worker auto-scaling and any stuck or slow stages if the DAG delegated to Dataflow. Verify whether a transient upstream failure triggered retries that pushed the run past the SLA window. Check if a backfill is needed to catch downstream tables up, and once resolved, add alerting on the DAG SLA directly. Airflow supports SLA misses as a first-class alert rather than only discovering staleness from downstream dashboard complaints. Great. Moving on. Question 9. Observability. Firewall governance. How would you design firewall rule ownership, logging, review, and cleanup across many GCP projects? Here's a strong way to approach it. Require every firewall rule to be created via Terraform, not console, with a mandatory owner tag or description, and enable firewall rule logging so usage is visible, not assumed. Run periodic reviews, quarterly, using logging data to identify unused rules and flag overly broad rules, 0, 0, 0, 0 or 0 source, for justification, and centralize rule management for shared or shared VPC networks so ownership and review responsibility is clear rather than scattered across every team with console access. Alright, next question. Question 10. SRE or reliability. ML feature store. What reliability and governance concerns would you consider for an ML feature store? Here's a strong way to approach it. Reliability concerns include feature freshness. Is the feature actually up to date when served? Training or serving parity, identical computation logic for both paths, and availability of the online serving path under load. Since a feature store outage can silently degrade every model that depends on it. Governance concerns include feature ownership and documentation, so teams don't duplicate or misuse features, access control for sensitive underlying data, and versioning so a feature definition change doesn't silently break models trained against the old definition. Let's keep going. Question 11. GKE or Kubernetes. Crash loop back off. A pod is stuck in crash loop back off in production. Give me your exact Kubernetes troubleshooting workflow and the commands or signals you would check. Here's a strong way to approach it. Start with kubectl describe pod to see recent events and the last termination reason or exit code, then kubectl logs.